NCBM 0324, Section 1.4, Evaluating Functions Using Function Notation, Part 2. So let's look at some more examples, some that may be a little bit more involved. They have different operations. On the next one, we have g of x is equal to x squared minus 4x plus 4. And eventually, we're going to find g of 5. So noticing our function here, we have x's in two places, and we have a power, so we're going to use our exponent rules of the order of operations. But even though we have x's in multiple places, that still means we're going to substitute the x variable with whatever they're telling us to plug in. So our skeleton, those blank spaces that we had previously, still go with these other powers, the other operations. So we're going to have g of whatever's on the inside is equal to that inside part squared, and replacing the x with the blank parentheses here, minus 4 times that same value. So we're plugging in the same number, in this case, in two places. And what is that number? Well, we're going to plug in the 5. Right? We're finding g of 5. What is the value of my function at x equals to 5? So by the skeleton, those blanks get replaced with that same number, in this case the 5, and then we get to evaluate. So exponents come first. We're going to do 5 squared, that's 25. If we feel comfortable, we can do the multiplication as well. So we could say 5 times the 4 will be minus 20, since that subtraction there. And then plus the 4 on the outside. Notice that this 4 hasn't changed. There's no x attached to it, so it's just a number being added. And then we'll have g of 5. Let's see, 25 minus 20, well, that's 5. Plus 4, that's my last piece here, and 5 plus 4 is 9. So g of 5 is equal to 9. The y value is equal to 9 when I plug in an x of 5. So we're just simply plugging in, right? That's what a lot of this notation is going to boil down to, is plugging in whatever they supply for me in these cases. Or sometimes maybe we have to pick the x value. There'll come a time where we're going to end up picking the x value. Let's try the next one. So I'm going to jump down here to f of x is equal to negative 7x plus 2. So pretty straightforward function, right? No exponents this time. I mean, in fact, before we even look at what we need to find, let's maybe do our skeleton. So wherever there's a variable, I'm going to leave a blank because I know that's where I'm going to plug something in. So there's my skeleton, blank, blank. Whatever's in this spot is going to go into this spot here, exactly whatever's in there. So the first one, f of 4, we're finding the value of our function at 4, the y value when x is 4. So going by my skeleton, 7 times, there's the blank, my substitution step. I'm going to plug in the 4. So then I will say, by order of operations, negative 7 times 4 is negative 28 plus 2. So we have f of 4 is equal to negative 26. Right? Not bad. Now with that same function, the negative 7x plus 2, the next one's asking us about f of a. F of a. So something a little bit different. We've been looking at plugging in numbers, but now we have a letter. Well, it doesn't really matter that it's a letter. What matters is that it's on the inside of those parentheses. Remember, the skeleton is telling us whatever's on this inside of this function notation is going to be plugged into the spot that used to have a variable, right? The x is that blank spot there. So exactly like we did with the 4, I can set up my skeleton here, the negative 7 blank plus 2, right? The multiplication here plus 2. And what do I put into this spot here? Whatever was on the inside of my function, which is, in this case, a. So in reality, can I multiply -7 times a? Well, I don't really know what a is. So I really can't do much with this other than saying f of a is simply equal to -7 times a plus 2. And that can be a little bit tricky to think about. You know, we're not always going to get a number. In this case, because they're giving us another letter to plug in, my answer will still be an expression, right? It'll still be some operation that I'm going to have to complete later on. And why do we need to switch into another variable? Well, there will be some cases where that's needed, right? So whatever's inside, the key thing right now, whatever's inside gets plugged into that x spot. The last one here, we have f of x plus 1. All right, we're upping the ante a little bit on this one. But the same setup, the starting point of these evaluations always begins with that skeleton. Just to kind of get us in that habit of we're going to plug something in to this spot here, wherever the original variable was. So I have my skeleton, -7 times the blank, space that we're going to fill in, plus 2. In this case, that blank is not just a number, not even a single letter, but it's a number plus a variable. It's that x plus 1, right? Variable plus a number. So this x plus 1 is taking the place of that blank, of that x spot that we previously had. Now it's a little bit confusing maybe because I have an x here and there was an x in my original function. Think of this original one though over here as your placeholder, right? That's where we were going to replace things. That's just a position, right? The operation times the -7 in front. It's holding that position for us. So whatever's inside the parentheses, that's what gets plugged in to that spot. Well, from this point, -7 parentheses x plus 1 plus 2, I can do a little bit of work. I can distribute that -7 through, right? Because now in this case, the parentheses does mean multiplication. And that'll give me -7x minus 7 plus that 2. Then I can combine my constant terms, the -7 plus 2. Then I'll have f of x plus 1 is equal to -7x minus 5. And there it is. And since our evaluation plug-in part has a variable in it, an x, we don't know what that number may be, our answer should also have one. And that's okay. It's almost like we're building a new function from our previous one using this new substitution.